All right, so this is what we did yesterday, which is find all the factors. So, right, it's 1 times 24, it's even, so it's 2 times 12. I'm going to leave myself more room because 24 has a bunch, right? 2 plus 4 is 6, so 3 must be there. If you should know your 3 times table, though. 3 times 8 is 24. 4 times 6 is 24, and it's not on the 5. Those are the factors of 24. 100, we did these yesterday. 1 times 100, it's even, so 2 times 50. 3 doesn't work, but 4 quarters and a dollar. 4 times 25, 5 times 20, and 10 times 10. All the factors of 2 are 1 and 2. So what kind of number has only 1 in itself as factors? We talked about this yesterday. A prime number. 13 is also prime, right? Because 1 times 13 is 13. 13 is also prime. So 2 is prime and 13 is prime. Now, some people think only odd numbers can be prime, but there is one even number, the number 2, that is prime. All the other even numbers have 2, have 1 in itself plus 2 times something. So we're going to do prime factorization, and this is the wrong number. It should be 2.2 there. All right, so a number that is only divisible by 1 in itself is called prime. We said that yesterday. The number 1, though, is not prime because it doesn't have 1 in itself. Right? 1 times 1 is 1, but that's 1 in itself. And people have argued about this. So you're not alone if you're a little shaky on that. But that's what math people finally agreed on, that 1 is not prime because it doesn't have 1 and something else. It just has 1. The number 2 is the only even number that is prime. So it says list the first prime number. So the first prime number is always 2. Right? 3 is prime because only 1 times 3. But 4 is not prime because 4 has 1 and 4 and then 2 and 2. So it has this extra number. So it's not prime. 5 is prime because it's just 1 times 5. So the rest of the even numbers we can just forget about. All right, but it's not every odd number either, but no more even numbers after 2. Then there's 7, because 1 times 7 is only 7. But then 9 is an odd number, but it's not prime, because there's 1, there's 3, and 9, right? 3 times 3 is also 9. The next odd number is 11, and 11 is prime. So we've got 5 of them. 13 is prime, 1 times 13, but 15, no way. 1 plus 5 is 6, right? So it's on the 3 times table, it's on the 5 times table. 17 is prime. 19 is prime. But 21, no way. That has 3 times 7, so that's not prime. 23 is prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need one more. No way, not 25. Right, that's 5 times 5. Not 27 either, because that's 3 times 9 in there. Yeah, it's 29 is the 10th prime number. All right, so now we're going to factor all the way down to just prime numbers. And this is called a factor tree. So instead of doing a list, what you do is you make a tree. So we're going to put 24 at the top. And really, I'm going to redo this because you want to be able to spread out. And you can do a factor tree. It's actually easier than what we did yesterday because you can do the factors in any order you want. The tree will come out because all we care about is the bottom of the tree, and we'll see that. All right, so 24 you have many choices. So let's pick 4 times 6, all right? So then you look and see if 4 and 6 are prime numbers. Well, neither of them are prime, so you go again. 2 times 2 is prime. 2 times 2 is 4, and both 2 are prime. So that's a bot. So once you reach a prime number, you stop the tree there. But we still have 6 to do. 6. How do you multiply to make 6? Oh, 2 times 3. So the prime factors we're going to write it this way: 2 times 2 times 2 times 3. Right? If you multiply that all together, that will make 24. Okay, so that's how we're going to write You just multiply together the bottom of the tree. All right, so here's 100. And again, you can pick any combination and you will get to the same answer. So let's see. Let's do 4 times 25, 4 quarters and $1. The 4 makes 2 times 2 again. The 25 makes 5 times 5. So the prime factors of 100 are 2 times 2 times 5 times 5. You multiply that together, you get 100. So let's just do one where I take another path. So let's do 100, but this time let's do 2 times 50. Well, 2 is prime, but for 50 you got to go again. Well, you can go 2 times 25, right? And there's the 2 2's, we got those, and there are the 2 5's again. And this will happen no matter which path you take. You will get the same bottom of the tree. Now, anytime, this doesn't seem like the bottom, but it's anytime a branch ends, right? Anytime it reaches a prime number, the branch is ending, and that's one of the prime factors. So that's what we're doing today. Prime factorization, it's called. Right, so it says, right, so on the test, you have to read whether it says prime factors or factors. This is prime factors. So you can do 6 times 8 or something else. Well, how do you multiply make 6? And by the way, writing 1 times 6 is worthless. We never do that, right? Because it doesn't get you anywhere. So you write 2 times 3. Those are both prime. Here we can write 2 times 4. 2 is prime, but 4 is not. And so we write 2 times 2. Now, typically when we write answers for this, you put it from lowest to highest. So we have 4 2's being multiplied, and then 1 3. Okay. So 15 is 3 times 5, and those are both prime. You're done. It's 3 times 5. That's it. All right, we're practicing 72. Well, I know that 8 times 9 is 72. Hopefully you do too. Then 2 times 4, and then 2 times 2, and 3 times 3. So we have 2, 2, 2, 3, 3. So it's 2 times 2 times 2 times 3 times 3 are the prime numbers that multiply to make 72. 84, hopefully you know the 7 times 12 is 84. And then 7 is prime. And so 12, we have 3 times 4, and then 2 times 2, and then once again we're going to put it in order from smallest to largest, and that's what you get as the prime factors of 84. 125. Well, good news, we could do 5. Well, we could do 5, and it's 5 times 25, right? 5 is prime, and then 5 times 5, and so the prime factors of 125 is just 5 times 5 times 5.